Assalamu alaikum wa rahmatullah. Good morning, my dear students. See, in this series or on today's class, we are going to understand the concept of algebraic identities. So, I'm going to discuss about grade 9, chapter polynomials, and the concept is algebraic identities. Okay. So, before going to this, I request everyone to take your running notes or classwork, and while I'm explaining, please note down the important points, and also wherever you get doubt, pause it, re-watch it, and try to understand the concept. And one more suggestion I want to tell you is, if the explanation, if you feel it is slow, watch it in 1.25x speed. Okay, so by this you will not feel the explanation slow, and also you will understand the concept. Okay, and now let us see. So algebraic identities. So algebraic identities. Okay, so coming to algebraic identities, we have already studied in grade 8. In grade 8, we have studied 4 algebraic identities. Okay, so what's the number one? It is x plus y whole square equals x square plus 2x plus y plus y square. And the second one is x minus y whole square. So the terms will be same, x square, 2xy and y square. The only difference is, since you have negative over here, you get negative before the middle term. Okay, now the third one is x square minus y square. So it is x plus y times x minus y. Okay, and the fourth one is, if you have any two expressions in the form of x plus a into x plus b, so it is x square plus a plus b times x plus ab. See, we use these algebraic identities. We have used these algebraic identities to simplify the expressions. Okay, and also we have used them for factorizing the expressions. Okay, let me explain you how we have done it in the previous classes. So let us see it. So for example, if you had a square plus 2 and 4a. Okay, sorry, it's not 2, 4. Okay, what we have done, actually before that, let me explain you. If you have x plus 9 whole square, so using our algebraic identity x plus y whole square, so which is x square plus 2ab plus 2xy plus y square, we have used, this is in place of x and this is y, right? So in x square we have written x square plus 2xy 2 times, what is in place of x over here? It is x, times what is in place of y? 9, plus 9 square, in place of y it is 9 square. So that equals x square plus 9 2s 18x plus 9 square is 81. So this is what we have done. See, one mistake students generally do this. What is the mistake which generally students do is, they add 18x and 18, or they add x square and 18x as 19x square. Can you add these three different terms? See, there are three different terms. You cannot add x square to x, because they are not like terms. In the same way, you cannot add 18x to 81 because they are unlike terms. You have x over here, and this is a constant, there is no x. So therefore the answer is x square plus 18x plus 81. You cannot simplify this. You cannot simplify this. Understood? So what we have done here, so this is how we have used algebraic identities to to expand or to simplify the given expressions. Okay, so now let us see how we can use these expressions for what is this called as, for simplifying or for uh, factorizing the algebraic expressions. For example, see, when to use and how to use, let me explain you. Very simple. See, if you are expanding the given things, if the first term is x and second term is y, whatever it is, or sometimes they will give you directly, or they'll give you a product of two expressions. Now when they give you product of two expressions like this, check the first two terms, are they equal, and check the next two terms. Okay, if they are equal and also if the sign is same, so then you have to go for the first identity, which is nothing but x plus y whole square is equal to x square plus 2xy plus y square. Sir, can you explain, sir? Yes. Let us take an example. 2y plus 3 times 2a plus 3. See, now in order check the first term, it is 2a and 2a. Okay, and what is second term? It is 3 and 3. Are first terms and second terms of both the expressions same? Yes. And what is the sign you have in between? What is the operation you have in between? It is plus. So everything is same. So it looks like x plus y whole square. Is it right? So then that means 2a plus 3 whole square, right? So since we are multiplying two expressions with same terms, we use 2a plus 3 whole square. So let us write the identity. X plus y whole square is equal to x square plus 2xy plus y square. Okay, what is in place of x? 2a. What is in place of y? 3. So what is the identity? X square. So what is in place of x? 2a whole square plus 2xy. 2 times what is in place of x? 2a. And what is y? It is 3 plus y square. What is in place of y? 3. 3 square. See, since you have in place of x 2 and a, okay, that is the reason I have kept them in brackets. Okay, now 2a whole square, let me do it in rough. You are not supposed to do it in left hand side, but since I don't have place, I am doing it. 2 2s are 4 and a into a is a square. So it is 4a square plus, now multiply the constants. 2 2s are 4, 4 3s are 12, and you have a plus 3 square is 9. So now can you simplify this? 4a square and 12a, can you add? No, we cannot add. Okay, because it is a square and here the variable is a. And in the same way, can you add 12a and 9? No, we cannot add. So therefore, see, conclusion is a very important. 2a plus 3 times 2a plus 3 is equal to 4a square plus 12a plus 9. Got it? How to simplify this? So now let us see the second one. If you have x minus y whole square, what does x minus y whole square means? It is x minus y times x minus y. So when you multiply two terms with the same first term, two expressions with the same first term and same second term and same sign in between, it is in the form of x minus y whole square, and which is nothing but x square minus 2xy plus y square. Sir, how to remember all these things? It's very simple, my dear friends. It is very simple to remember. The only thing you have to do is, for each problem, whenever you do each problem, you write that identity in that problem. The more you practice, the more you will remember. So x minus y whole square. For example, how to do it, sir? So 5a minus 3b whole square. How to do it? So it is in the whole square. What is the identity? X minus y whole square. What is in place of x? 5a. What is in place of y? 3b. And somebody do a mistake over here. Sir, in place of y it is minus 3b. No, my dear friends, it is not y minus 3b, because here when you match the signs, both are same. So you have to match only the term, not the sign. When sign or operation matches. So 5a minus 3b whole square, in place of x you have 5a and in place of y it is 3b. So therefore, substituting here x, it is 5a whole square minus 2 times what is in place of x, 5a, multiplied by what is in place of y, 3b, plus y square, what is y, 3b whole square. That is equal to, what is 5a whole square, as we have done. Okay, and now I will do it on right hand side. So 5a times 5a, 5 5s are 5, 25, a times a is a square. So it is 25a square minus 2 5s are 10, 10 3s are 30, 30ab plus 3b whole square. So multiply in rough, don't do it directly, you will get confused. So 3 3s are 9, b times b is b square. So this is 5a minus 3b whole square. Conclusion is very important whenever you learn. 5a minus 3b whole square equals 25a square minus 30ab plus 9b square. So this is the answer. So let us see now the next one. For example, when you have two different expressions with same first term and last term, that means here also you have 5 mn minus 7n times 5 mn plus 7n. See, what is the speciality in this problem? The first terms are same and also second terms are same, but the signs are different. Is it right? The signs are different. So when you have this, the formula is a plus b times identity. A minus b equals a square minus b square. Okay. So here also you have first terms equal. That means what is first term? A, and what is b? 7n. First term is a, which is 5mn, and second term is b, which is 7n, and you have signs different. Here also you have plus and minus. So the identity is a square minus b square. So if you have, say I am drawing arrows, actually in examination instead of drawing arrows you write like this. 5 is a is equal to 5mn and b is equal to 7n. So what is the identity for this? A square minus b square. What is a? 5mn whole square minus what is b? 7n whole square. As I told you, I have one constant variable, so therefore keep it in bracket. Okay. Now following this algebraic identity, following the law of exponent, ab whole to the power of m will be, the power will be distributed to both the terms, a to the power of m times b to the power of m, right? So in the same way here, square will be distributed to all the three all constant as well as the variables. So that equals, it will be written as 5 square times m square times n square minus, here it will be distributed to 7 as well as n square. So that is equal to 25 m square n square minus 49 n square. Now my question, last question is, can we add or subtract 25m square n square minus 45n square? So you may say that, sir, here all in the first term also we have n square and second term also we have n square. So can we do it? No, we cannot do it because the variable is entirely different. The first one has n square and the second one has only n square. So we cannot do it. So this is the simplified answer. Therefore, 5mn minus 7n times 5mn plus 7n is equal to 25 m square n square minus 49 n square. Understood, my dear students? So now let us see the next one, the algebraic identity which we have learnt, which is nothing but x plus a times x plus b equals x square plus a plus b times x plus ab. So that means what? Here what can you observe? Sir, we can observe that here the first terms are equal and the second terms are different and you have the same sign. Okay, so now what to do, sir? So let us see. Let us take an example. What is the example? So let us take an example. 5d plus 9 multiplied by 5d minus 10. See, you may say that, so in the identities, sir, both are positive. Okay, so let us see here. See, x, the first term is same, right? 5d and 5d. And the second terms are different in both the expressions. So now let us compare. Let us compare. Sir, what is in place of x? 5d. And what is in place of a? Since the signs are same, a is equal to 9. I will not change it. Now what is in place of b? Sir, in place of b I can see 10, but since the signs are not same, so can I write this as 5d plus of minus 10? Can I write this? Because plus of minus is minus. We have already studied in integers. So 5d plus of minus 10. Okay, so that means what is in place of b? In place of b we have minus 10. I hope everybody understood this. If you have any doubt, please let me know. So let me know in the comments, I'll explain you. Or you can directly message me. You can directly message. So now understood how to compare, my dear students. So this is how we compare. And now let us continue. That is equal to, that equals, how will you write this? That equals x square. So what is in place of x? 5d whole square plus a plus b. What is a? 9. And plus what is b? Minus 10. Whenever you have negative, keep bracket and bracket close into x. What is x? 5 into d. Okay, plus what is ab? 9 times minus 10. See, just it is very easy. If you do it 2 times, you will understand. Okay, it is only understanding what is a x, what is a, and what is b. And once you get the terms, so substitution. Don't forget it. Okay. Now 5d square. If I do it in rough, 5d times 5d. So it is 5 5s are 25 d square. Now plus here whenever we simplify we have to use BODMAS, right? So BODMAS brackets. So therefore we have to, before doing multiplication, let us simplify it, the brackets. 9 plus of minus 10. See, let us do it in rough. Plus of minus 10. What is 9 plus of minus 10? 9 plus of minus is minus 10. So 9 minus 10. 9 minus 10 is equal to minus 1. Minus 1 times 5d. And here plus of minus 9 tens are 90. So that equals 25d square plus of minus is minus, sorry, plus or minus is minus 5 times d minus 90. So the same question, can we simplify any of these terms? No, because they are not like terms. So therefore 5d plus 9 times 5d minus 10 equals 25d square minus 5 times d minus 90. Is it right? Now let us see, my dear students, how to use this in terms. Let us recall the identities and use them. So which identity is used here? Can you tell me? Yes, the fourth identity, because the first terms are equal and second terms are different. So let us do the first one. What is the identity? X plus a times x plus b equals x square plus a plus b times x plus ab. So that equals, let us see what is in place of x. It is x itself. So shall I write it? So x is equal to x, and what is in place of a? A is equal to 4, and what is in place of b? So b equals 10. Let us substitute. That is equal to x square. You have x plus what is a plus b? 4 plus 10 times x plus what is ab? 4 into 10. So that equals x square plus 10 plus 4. Sorry. Yeah, 4 plus 10. 4 plus 10 is 14x plus 4 times 10 is 40. Is it right? Did you understand the first one? Let us see the second one. See, first terms are same and second terms are different. So we have to take the same x plus a times x plus b. So just now we have done. Why are you writing the identity one more time? See, since I write formulas or identities wherever I use it, so I remember them. So I suggest you to do the same. Okay. So now let me write what is in place of x, and what is in place of a, 8. What is in place of b? Sir, since the signs are different, shall I take it as b is equal to minus 10 as we have done? Chalo. Let us solve this, and by substituting in place of x you have x square plus a plus b, 8 plus of minus 10 into x plus a into b, 8 into minus 10. Is it right? That is equal to x square plus plus 8 plus of minus 10. We have seen in integers, when we one positive, this is positive and this is negative. So one positive and one negative, you have to subtract. So 10 minus 8 is 2, and the sign of the bigger number is minus, so keep it as minus times x plus 8 into 10 is 80, and since you have minus, it is minus 80. Keep it in brackets. So that is equal to x square plus into minus minus 2x plus into minus minus 80. I hope you understood these two problems. Okay. So let us go for the next one. Here also you have the same. First terms are equal and second terms are different. So I'll leave it for you. Okay, do it as homework, or shall I explain? So let me see, what is that? 3x plus 4. So it was 3, excuse me, yeah. So it was 3x plus 4 times 3x minus 5, right? First terms are equal and second terms are different, and signs, no, don't bother about signs. because when first term is the same and the second terms are different, we have to use the fourth identity. So what is fourth identity, my dear? X plus a times x plus b equals x square plus of a plus b times x plus ab. So now let me write what is in place of x. What is in place of x? You have 3x. What is in place of a? A is 4. What is in place of b? It is not 5, it is negative 5 because the signs are not matching. So that is equal to, how will you write it? Substitute now. In place of x, 3x whole square plus a plus b times x. A means 4 plus of minus 5 time bracket close into x plus ab 4 times of minus 5, that is equal to 3x square. Can I write it as 9x square plus 4 plus of minus 4. What did I tell you? When one is positive and another one is negative, you have to subtract 5 minus 4, 1. So, but the bigger number has minus sign. This is the bigger number 5, so it has minus 5. So it is minus 1 into x plus 4 into minus 5, it is minus 20. And when I simplify the signs, 9x square plus of minus minus x minus 1x, 1x or x, both are same, plus of minus 20. So we cannot simplify this. So what will you write? Therefore 3x plus 4 times 3x minus 5 is equal to 9x square minus x minus 20. I hope understood, right? Let us see the next one. Y square plus 3 by 2 minus, okay, let us see this. Let us see this. So what is this? What is it fourth or third? Let me check. Fourth one, y square plus 3 by 2, right? Chalo. Y square plus 3 by 2 times y square minus 3 by 2. See, whenever you see a problem, you have to just focus and think. Are the first terms equal? Yes, sir, they are equal. Are the second terms equal? Yes, sir, they are also equal. But you have a change in sign. So when you have positive and negative with first term and second term equal, what you are supposed to do? You are supposed to use the third identity. A plus B times A minus B. What it will be? A square minus B square. So that means let me explain you clearly. So that means what you are supposed to do, my dear students. So you have to substitute the values. So before substituting values, what is A? A is equal to y square. And what is B? B is equal to 3 by 2. So let us do that is equal to, in place of A it is y square and you have square. So therefore whole square minus, what is B? B is 3 by 2 and you have whole square. So if you have power over power, we have studied a to the power of m whole to the power of n is equal to a to the power of mn. So it is y to the power of 2 into 2 minus, and what is this? You have a fraction and you have power on it. So the power will be distributed to numerator as well as denominator. So it will be 3 square divided by 2 square. So that equals y to the power of 4 minus, what is 3 square? 9. What is 2 square? 4. So it is y square minus 9 by 4. Understood, my dear students? So let us see the next one. Next. So since we don't have place, which slide is not so better? Yeah, this is also important. So let us use this. Let us use this slide and do the last problem. What is last problem? Problem 3 minus 2x into 3 plus 2x, right? So 3 minus 2x plus 3 plus 2x. So this is the fifth problem, I believe. 3 minus 2x times 3 plus 2x. Now students, I'll pause this video and just let me know which identity we have to use. Yes, mashallah. Now let us see. See, you have the first terms equal. Yes sir, they are equal, and also second terms are also equal, but you have a difference in signs. So what is the identity we have to use? We have to use the third identity, right? So what is the third identity? The third identity is a plus b times a minus b, that equals a square minus b square. Now what is in place of a? A is 3, and what is in place of b? B is equal to 2x. Sir, you may tell that sir, the signs are not matching, so how can you take it as 2x? My dear friends, when you multiply two terms or two numbers or two expressions, multiplication is satisfied for cumulative property, right? So that means you can multiply either ways. So I have taken a plus b, which was second, and a minus b, which is first expression. So I can use cumulative property, so I can use it, right? Understood everybody? Any doubts? If you have any doubts, please let me know. So so now let us do this. A square minus b square. What is a square? It is 3 square minus 2x square. Can you write 2x square? No sir, you cannot write. You have to keep in bracket because you have a number and a variable in multiplication. So when you are squaring it, you have both of them. You have to keep them in bracket. So that is equal to 3 square is 9 minus, here the square is distributed, 2 square times x square. So that is equal to 9 minus 4x square. So this is the identity. So therefore write the conclusion. It's very important. So I hope you understood how we use our what is that called as algebraic identities, right? Algebraic identities. So now let us see. Let us see. So in this video we have seen grade 9 polynomials, algebraic identities, and we have seen the algebraic identities, and we have recalled the all algebraic identities which we have done in grade 8. Okay, grade 8. So let us see in the next video the problems of the remaining problems of the exercise, and also the new identities which we are going to see in grade 9. So my dear students, please practice and repeat them. Until and unless you repeat, you cannot understand algebraic identities, and you don't know. While listening you will feel it's very easy, but while doing it practically it will be very difficult. So my dear students, please practice, and if you understand the concept, leave a comment and like the video, because just came to know that the more you press the like button, it will be shared by the YouTube. The YouTube algorithm will share it to most number of people, it seems. So that the students can get benefited. Okay, take care and bye. Wait for the next video to understand the remaining things. Okay, to remaining problems, explanation of the remaining problems. Thank you, take care, bye.